The Pacific Ocean has just done something it has only done a handful of times in the historical record. It rapidly transitioned out of La Niña in the exact configuration that produced Katrina, Harvey, and Maria, and it did it on top of an Atlantic basin that is now warmer than every analog season on record, including the season that gave us 30 named storms and exhausted the entire Greek alphabet. Hurricane forecasters have moved into their strongest preseason language since 2020. The 2026 season opens in 35 days. Here is the exact setup they're warning about, and why the next 4 weeks may be the most consequential preseason window in 20 years. Let's get into it. The National Hurricane Center will resume its routine tropical weather outlook issuance on May 15th, less than 3 weeks from now. The official Atlantic hurricane season opens on June 1st, and in the past several days, hurricane researchers have moved into the strongest preseason language used since 2020. This is not about a single storm. There is no system in the Atlantic right now. What there is, instead, is a structural setup. 3 separate indicators that hurricane forecasters watch every spring have all moved into the same configuration at the same time. And in every prior modern instance where these 3 indicators lined up the way they have right now, the Atlantic produced an above-normal hurricane season. The first indicator is the El Niño Southern Oscillation. The Pacific Ocean has just completed one of the fastest cool-to-warm transitions in the historical record, moving out of La Niña and into neutral conditions in only 5 months. The second is the Atlantic Ocean baseline. The basin entered spring with surface temperatures that did not cool down the way they normally do over the winter. And the third is the depth of warm water in the Caribbean and the Gulf of America, which has been documented at record anomalous levels by recent University of Miami and NOAA oceanographic work. Together, those 3 indicators describe a setup that most closely resembles the year 2005. That is the year that produced Hurricane Katrina, it produced Rita, and it produced Wilma. The 2026 setup looks like the 2005 setup with one critical difference. The underlying ocean is now warmer than it was in 2005, which means the analog season may understate, not overstate, what the 2026 atmosphere has to work with. That is what this video is going to break down. The 3 indicators, the analog seasons, the rapid intensification dynamic that defines modern Atlantic hurricane risk, and what to watch for in the next 4 weeks before the season officially opens. Let's start with the Pacific. The Oceanic Niño Index is the standard measure that hurricane forecasters use to track the state of the El Niño Southern Oscillation. It is a 3-month running average of sea surface temperature anomalies in a specific patch of the equatorial Pacific Ocean, called the Niño 3.4 region. When that average is below negative 0.5, the Pacific is in La Niña. When it is above positive 0.5, the Pacific is in El Niño. Anything in between is neutral. 5 months ago, the Oceanic Niño Index sat at minus 0.55. The Pacific was firmly in La Niña conditions. As of the most recent measurement, the index sits at minus 0.16. That is a warming of nearly 0.4 of a degree Celsius in 5 months. The La Niña has dissolved. The Pacific is now in neutral territory, and the trajectory is a clean monotonic warming line over the past 3 seasons. Why does the Atlantic care about the Pacific? Because El Niño years produce enhanced upper-level westerly winds over the Caribbean and tropical Atlantic. Those winds increase what meteorologists call wind shear, which is the change in wind speed and direction with height. Wind shear is the primary atmospheric suppressor of tropical cyclone development. A storm trying to organize into a hurricane needs a relatively quiet vertical column of atmosphere to build its inner core. Strong wind shear tears that column apart and prevents the storm from intensifying. So when the Pacific is in El Niño, the Atlantic gets shear suppression and produces fewer storms. When the Pacific is in La Niña, the shear relaxes and the Atlantic produces more storms. The 2026 setup is in the configuration between those 2 states. The basin is no longer in La Niña, but it is not yet in El Niño either. The Pacific would need to warm a further plus 0.66 to cross the El Niño threshold. And here is the part that has hurricane forecasters paying attention. The neutral warming toward El Niño configuration is, historically, the most permissive Atlantic configuration that exists. The basin retains the La Niña favorable warmth that built up during the previous cool phase, while the developing El Niño circulation has not yet had time to translate into actual Atlantic shear suppression. The years 2005, 2017, and 2020 all open from variations on exactly this configuration. The most likely scenario in the NOAA Climate Prediction Center probabilistic outlooks shows ENSO neutral conditions persisting through the early hurricane season, with a rising probability of weak El Niño conditions developing in late summer or autumn. which means the favorable window for Atlantic ramp-up extends through June, July, and August. That is the window when Cape Verde-type hurricanes, the storms that produce the majority of major Atlantic landfalls, typically begin firing off the coast of West Africa. The Pacific is not the only ocean misbehaving. The bigger story is in the Atlantic itself. Sea surface temperatures across the tropical North Atlantic have remained at record near levels through the boreal winter. That sounds like a routine statement, but it is not. In a typical year, the winter season removes a substantial fraction of the previous summer's ocean heat. Stronger winter storm tracks mix the upper ocean. Latent heat loss from the surface cools the water. Convective cooling pulls heat out of the system. By the time spring arrives, the basin has reset to something close to its climatological baseline, ready to begin warming back up through the early summer. That did not happen this year. The 2025 to 2026 winter failed to remove the residual heat from the previous summer's anomaly. The Atlantic basin entered April 2026 with surface temperatures that, in a typical year, would not appear until late May or early June. The basin has, in effect, skipped roughly 6 weeks of normal seasonal cooling and is starting the spring already warm. There is a baseline contribution to this from the Atlantic multi-decadal variability, which is the natural multi-decade oscillation in basin-wide Atlantic sea surface temperatures. The AMV has been in its warm phase since approximately 1995, contributing a baseline elevation that explains part of the elevated activity over the recent decade. But layered on top of that natural baseline, the years 2023 through 2025 saw multiple instances of Atlantic sea surface temperature anomalies that exceeded any previous instrumental record. The 2026 season is beginning before that anomalous heat has been removed. Here is why that matters for hurricane intensity. There is a fundamental thermodynamic ceiling on how strong a hurricane can get, set by the temperature differential between the ocean surface and the upper troposphere. Meteorologists call this the maximum potential intensity. As the ocean surface warms and that ceiling rises, the relationship is roughly linear. A storm forming over water that is 1 degree Celsius warmer than climatology can, in principle, reach winds approximately 5% stronger than its climatological maximum. The 2026 Atlantic enters the season with surface waters that are well above climatology across most of the basin's storm formation zone. The most important specific area to watch is the main development region. That is the strip of ocean between roughly 10 and 20 degrees north latitude, west of the African coast. It is where the majority of major Atlantic hurricanes, Category 3 or stronger, actually originate. Approximately 85% of all major Atlantic hurricanes form there. The main development region in 2026 is running multiple standard deviations above its 1991 through 2020 climatological mean. The water that hurricanes will be born over this season is the warmest water this basin has ever measured for this calendar date, and the heat is not just at the surface. Hurricane intensification depends on something more specific than just sea surface temperature. It depends on the depth of warm water available. Here is why. When a hurricane passes over the ocean, the wind stirs the upper water layers, mixing cooler subsurface water up to the surface. If the warm layer the storm is sitting on is shallow, the storm churns up cool water and chokes off its own fuel supply. The intensification stalls. If the warm layer is deep, the storm can keep extracting heat for as long as its core remains over warm water. The specific oceanic structure that hurricane forecasters watch most closely is the loop current in the Gulf of America. The loop current is a stream of warm water that comes up from the Caribbean, loops north into the Gulf, and exits through the Florida Straits. It carries some of the warmest and deepest warm water in the entire Atlantic basin. Storms that pass over the loop current have historically been the storms that produce the most extreme intensification events in U.S. landfall history. Hurricane Katrina passed over a warm loop current eddy before it reached its peak intensity. Hurricane Rita did the same. Hurricane Michael in 2018. Hurricane Ian in 2022, Hurricane Helene in 2024, all intensified explosively over loop current warm water. Recent 2024 and 2025 analyses from the University of Miami and the NOAA Atlantic Oceanographic and Meteorological Laboratory have documented that the depth of the warm water column in the loop current and across much of the Caribbean is currently anomalously deep. The depth of the 26 degrees Celsius isotherm, which is the threshold below which hurricanes cannot extract significant heat, has been displaced downward by tens of meters in some areas. The warm layer is thicker than it has been in the modern instrumental record. This is the structural condition that turned Hurricane Helene into a Category 4 within 24 hours of landfall in Florida in 2024. It is the structural condition that allowed Hurricane Milton in October of 2024 to undergo one of the most extreme rapid intensification events ever recorded, going from a tropical storm to a Category 5 in roughly 24 hours. The 2026 setup preserves that warm water column structure heading into the season. In some areas, recent measurements suggest it has actually deepened, which brings us to the trend that defines modern Atlantic hurricane risk. Rapid intensification is a specific technical term in hurricane meteorology. It is defined by NOAA as a sustained increase in maximum sustained winds of 35 miles per hour, or more within a 24-hour period. A storm that gains 35 miles per hour in a single day is undergoing rapid intensification. Rapid intensification used to be a relatively rare event. It still happened. Historically, roughly 15% of Atlantic hurricanes underwent at least one 24-hour rapid intensification cycle during their lifetimes. But over the past 4 decades, that proportion has roughly doubled. A 2019 Nature Communications paper by Bhatia and colleagues, using a multi-decade tropical cyclone dataset, demonstrated that the share of Atlantic hurricanes undergoing rapid intensification has approximately doubled since the 1980s baseline. Subsequent peer-reviewed work in geophysical research letters has reinforced that finding and pointed to deeper warm water layers as a primary driver of the trend. The mechanism is not fully understood, but the leading hypothesis attributes the increase to 3 things. Deeper warm water layers, which allow storms to keep extracting heat as they pass. Reduced atmospheric stability over the tropics, which makes it easier for storms to vent rising air through the upper troposphere, and possibly changes in the vertical wind shear distribution within developing storms themselves, which makes it easier for an inner core to stay coherent during rapid strengthening. Here is why this matters operationally for the 2026 season. A storm that gains 35 miles per hour in a single day removes roughly a full evacuation cycle from emergency planning windows. Coastal county emergency managers typically need 72 hours of forecast lead time to execute a phased evacuation of vulnerable areas. A storm that intensifies from a tropical storm to a Category 3 in 24 hours collapses that planning window. The forecast cone may have correctly identified the threatened region, but the warning time for the strength of the storm at landfall is effectively gone. The 2026 setup, with its documented loop current and Caribbean warm water column anomalies, is structurally favorable for continued elevated rapid intensification frequency. And this is the specific reason hurricane researchers are flagging this season's risk profile as elevated even before any storm is formed. Even if the total named storm count for 2026 lands in the moderate range, fewer than the 30 named storms of 2020, fewer than the 28 of 2005, the basin is still loaded for an outsized share of rapid intensification events, which means the operational worst-case scenario for any single storm is elevated regardless of the total count. There is one more piece of the rapid intensification picture that deserves attention. The cases that have produced the most catastrophic outcomes in recent years have not been the storms that rapidly intensified out in the open ocean and then weakened before landfall. They have been the storms that rapidly intensified within 24 to 36 hours of striking land. Hurricane Otis in October of 2023 is the textbook recent example. Otis went from a tropical storm to a Category 5 in roughly 12 hours and slammed into Acapulco overnight as a Category 5 with essentially no warning time for evacuation. Hurricane Ian in 2022 underwent a comparable late-cycle intensification before landfall in southwest Florida. Hurricane Helene in 2024 did the same. Hurricane Milton in 2024 did the same. The 2026 setup raises the probability of that specific scenario, a storm that intensifies dramatically inside the 72-hour evacuation window, because the warm water column structure that favors late-stage rapid intensification is in place across the entire approach corridor. From the Yucatan Channel through the loop current and into the eastern Gulf, the oceanographic conditions are configured to fuel intensification right up to the coastline rather than allowing the storm to weaken over cooler shelf water. This is the operational worst-case scenario that emergency managers in Florida, the Gulf Coast, and the Caribbean are watching most closely heading into June. That brings us to the seasons forecasters keep naming when they describe the 2026 setup. When hurricane researchers look for analog seasons, prior years with similar preseason ocean and atmospheric configurations, 4 specific years come up for the 2026 setup: the 2005 season, the 2017 season, the 2020 season, and the 2024 season. 2005 entered the season with ENSO in neutral conditions, tilted slightly cool, and with record warm Atlantic sea surface temperatures. The season produced 28 named storms, 15 hurricanes, 7 major hurricanes. It produced Hurricane Katrina, which made landfall in Louisiana as a strong Category 3 storm and killed more than 1,800 people. It produced Hurricane Rita, which struck the Texas-Louisiana border at Category 3 intensity. And it produced Hurricane Wilma, which became at one point the strongest Atlantic hurricane ever measured by central pressure. 2005 was, at the time, the most active Atlantic hurricane season ever recorded. 2017 entered the season with ENSO transitioning from weak La Niña toward neutral and with a warm Atlantic. The season produced Hurricane Harvey, which stalled over Texas and dropped historic rainfall measured in feet. It produced Hurricane Irma, which struck the northern Caribbean as a Category 5 and then made landfall in Florida. And it produced Hurricane Maria, which devastated Puerto Rico as a Category 4 and caused power outages that lasted for nearly a year. 3 Category 4 or stronger landfalls in the United States and its territories within roughly 5 weeks of each other. 2020 entered the season with ENSO transitioning from neutral toward La Niña and with record Atlantic warmth. The season produced 30 named storms. The standard alphabetical naming list, which contains 21 names, was exhausted. Forecasters then moved to the Greek alphabet for the first time since 2005, and they exhausted Greek as well. 2020 remains the most active Atlantic hurricane season on record by named storm count. 2024 entered the season with ENSO transitioning from El Niño through neutral toward La Niña and with record Atlantic warmth. The season produced Hurricane Helene, which underwent rapid intensification to Category 4 in the Gulf of America before making landfall in Florida and causing catastrophic inland flooding across the Appalachian Mountains. And it produced Hurricane Milton, which underwent one of the most extreme rapid intensification events ever recorded, going from a tropical storm to a Category 5 in roughly 24 hours over loop current warm water. The 2026 setup most closely resembles the 2005 and 2017 configurations in terms of ENSO trajectory and sea surface temperature anomaly. The defining difference is the underlying baseline. The 2026 ocean heat content exceeds all 4 of those analog years. Each of those analog seasons began from a warmer than average state, but the 2026 baseline is warmer still, which means the analog seasons may understate, not overstate, the energy available to the 2026 atmosphere. If the basin is crossed into a new, warmer operating regime, the 2005 and 2020 seasons, themselves the most extreme in modern record, may turn out to be the new median rather than the new ceiling. That is the specific data point that has hurricane forecasters using the strongest preseason language since 2020, not because they expect a single specific storm, but because the analog seasons that match this setup are the worst seasons in modern memory, and the baseline this time is even warmer than those seasons started from. There is one additional pattern from the analog seasons that deserves to be on the table. In every one of those 4 years, 2005, 2017, 2020, and 2024, the United States or its territories experienced at least one Category 4 or stronger landfall. In 2005, it was Wilma in Florida and Rita in Texas, Louisiana. In 2017, it was Harvey in Texas, Irma in Florida, and Maria in Puerto Rico. In 2020, it was Laura in Louisiana. In 2024, it was Helene in Florida and Milton in Florida. The preseason setup that produces an above-normal season has, in every recent analog case, also produced at least one major U.S. landfall. The 2026 setup matches the pattern. The implication is not certainty about any specific landfall. It is that the conditional probability of at least one Category 4 or stronger U.S. impact this season is meaningfully higher than the long-term climatological baseline would suggest. There is a separate trend hidden inside the recent decade of Atlantic data that deserves attention as the 2026 season approaches. A 2020 paper in the Proceedings of the National Academy of Sciences by Cosson and colleagues documented that the latitude at which Atlantic hurricanes reach their maximum intensity has shifted poleward over the past 4 decades. In plain language, hurricanes are reaching peak strength further north than they did mid-20th century. This matters for one specific reason. Historically, the United States eastern seaboard from roughly Virginia northward has been considered a lower-risk region for major hurricane impacts. Hurricanes typically weakened as they moved out of the warm Caribbean and tropical Atlantic into the cooler waters off the mid-latitudes. By the time a storm reached Cape Hatteras, North Carolina, or further north, it had usually weakened to a Category 1 or a Category 2. Major hurricane landfalls north of North Carolina have been historically rare in the modern record. That climatology is shifting. As the warm water belt extends further north, hurricanes are able to maintain their intensity to higher latitudes than they used to. A storm that would have weakened to a Category 2 off the Carolinas in 1980 has a measurably higher chance of remaining a Category 3 or Category 4 to those latitudes today. The 2026 baseline, with its anomalously warm Atlantic and elevated loop current heat content, is the kind of season that could accelerate this trend. The practical implication is that the 2026 season is not just a Gulf Coast and Florida concern. The mid-Atlantic states, the Northeast and southern New England, are facing a slowly increasing exposure to major hurricane impacts that the historical climatology of those regions does not capture. If the 2026 season produces a strong East Coast storm, the question of how far north it remains a major hurricane is one of the variables forecasters will be watching most closely. There are also a couple of things that could keep this from being a worst-case season. A loaded structural setup is not a guarantee. There are several variables that could turn the 2026 season into a quieter actual outcome, and any honest forecast has to account for them. The first wildcard is the Saharan air layer. Each summer, dry, dusty air outbreaks from the Saharan desert cross the Atlantic and suppress tropical convection through dry air entrainment and aerosol effects. The intensity and duration of those outbreaks vary substantially year to year, and they are not currently predictable months in advance. An unusually persistent Saharan air layer regime in the early summer can choke off the early season ramp-up entirely. Years like 2013, where the preseason setup looked active but the actual season underperformed, often had stronger than expected dust outbreaks. The second wildcard is African easterly wave activity. African easterly waves are the disturbances that emerge from West Africa each summer and serve as the seed disturbances for the majority of Cape Verde-type hurricanes. Wave activity in the recent record has been at or above climatological norms, but year-to-year variability is real, and a weaker wave train year would mean fewer initial seed disturbances even with all other conditions favorable. The third wildcard is the timing of the El Niño transition. If the developing El Niño in the Pacific moves faster than current models indicate and arrives by mid to late August, the resulting Atlantic shear suppression could moderate the peak weeks of September. The 2026 forecast assumes a relatively slow El Niño development, which leaves the favorable window open through climatological peak. A faster transition would compress that window. These are the variables that could turn a loaded setup into a quieter season. None of them are predictable enough at this point to incorporate confidently into a preseason forecast, which is why the setup-based concern remains the dominant signal. But they are the reasons hurricane forecasters always frame their preseason outlooks as probability ranges, not single-number predictions. And here is what to watch for in the next 4 weeks. The next 35 days are when most of the 2026 forecast picture will fill in. Here's the calendar, May 15th. The National Hurricane Center resumes its routine tropical weather outlook issuance for the Atlantic, Eastern Pacific, and Central Pacific basins. From that date forward, the NHC is publishing daily outlooks identifying any disturbances with potential for tropical development. Even early season disturbances that do not develop are tracked from this point forward. Late May, the NOAA Climate Prediction Center publishes its first 2026 seasonal outlook for the Atlantic Basin. This is the official U.S. government seasonal forecast and the most watched product of the preseason window. The CPC outlook will assign a probability to the season being above normal, near normal, or below normal, and will provide expected ranges for named storms, hurricanes, and major hurricanes. Throughout May, Colorado State University's Tropical Meteorology Project will update its early April outlook with a June revision. The UK Met Office, AccuWeather, and several private sector forecasters will publish their preliminary 2026 numbers. By June 1st, there will be roughly 6 to 8 independent seasonal forecasts available for comparison. Where they cluster matters more than any single number. Consensus across independent products is the strongest preseason signal forecasters watch for. June 1st. Atlantic hurricane season officially opens. From this point forward, any organized tropical system in the basin gets a name from the alphabetical list. The 2026 list begins with Andrea, then Barry, then Chantal. Early June. The first Cape Verde-type disturbances begin organizing off the coast of West Africa. The early season activity tends to be in the Western Caribbean and the Gulf, rather than the deep tropical Atlantic. But the basin's signature deep tropics activity picks up through June and accelerates into July. By Independence Day, the 2026 season will have committed to a trajectory. By the end of August, the bulk of the season's activity will be in motion. The seasonal peak runs from mid-August through mid-October. Here is the practical takeaway. If you live or own property anywhere from Brownsville, Texas to Boston, Massachusetts, or anywhere in the Caribbean, this is the year to verify your hurricane preparedness plan rather than assume last year's plan still applies. Confirm your evacuation route. Check your insurance coverage. Know where the nearest official shelter is. Have a communications plan with family members in case cell networks go down. None of this is panic. This is the same preparation any responsible coastal resident does every spring, but this is a year where the baseline risk is elevated enough that the routine matters more than usual. We will be tracking the seasonal forecasts as they land. Watch for the CPC outlook in late May. That will be the next major data point in this story. The Space Desk will be back with the breakdown when it drops.